Today we are going to discuss about homogeneous differential equations. To understand this, let us take few examples. Consider the following functions in x and y. First function is your f1xy is y square plus 2xy. Second is 2x minus 3y. Third is cos y upon x. And fourth is sin x plus cos y. Now if we replace x and y in these functions by lambda x and lambda y respectively, where lambda is some non-zero constant. So let us see what is going to happen. f1 of lambda x lambda y, you will put here lambda y, so it will become lambda square y square, and here 2 times lambda x lambda y, and you can take lambda square common and it will be f1 of xy. In the second function, f2 lambda x lambda y is lambda times, it will be 2x minus 3y, which is lambda times f2 xy. In the third one, f3 lambda x lambda y is cos of lambda y upon lambda x, which is cos of y upon x, right? So it becomes your lambda raised to power 0. Here no lambda is there, so lambda raised to power 0, f3 of xy. But in fourth function, you find that if you replace lambda x and lambda y with your x and y, then sine of it becomes sine of lambda x plus cos of lambda y, which is you cannot take out lambda common, and which will not be equal to of the form lambda raised to power n of f4 xy for any natural number n. So we observe that the functions f1, f2, f3 and f2, they can be written in the form of f of lambda x lambda y is equal to lambda raised to power n times f of xy, but this f4 cannot be written in this form, right? So here comes the definition of homogeneous function, that if function fxy is said to be homogeneous function of degree n if f of lambda x lambda y is equal to lambda raised to power n times f of xy for any non-zero constant lambda. So in a function f1, we find that lambda is having its degree as 2, for f2 it is having 1, and for f3 it is having lambda 0, whereas f4 is not your homogeneous function. The second thing which you can clearly see, this is the way how we check whether the function is homogeneous or not, that the degree of the terms, okay, degree of the variables in each individual term is same throughout, right? Y is having degree 2, so here the degree of 1x and 1y will make it 2. So both the terms is having degree same. Here also if it is 1, it is also 1. For here y is having 1, x is having 1, right? Whereas in this case, with the help of degrees, you cannot check it. So this is the best way of checking by replacing x and y by f of lambda x and lambda y. So these are various examples with the help of which you can check that a differential equation of the form dy by dx is equal to f of xy is said to be homogeneous if f of xy is a homogeneous function of degree 0. And to solve a homogeneous differential equation of type dy by dx is equal to f of xy, in which we can either express it in the form of g of y upon x, we make the substitution y is equal to v into x. Now what we do, we differentiated both sides of this equation, so it becomes dy by dx equal to v plus x dv by dx, right? And replace this dy by dx in equation number 1 with this this value, and the whole of the question will change in the form of x and v, and you will get a function which is reduced to the variable separable form, and integration can be further done, right? So, and if it is the second form is your differential equation is of the form of dx upon dy is equal to f of xy, there we make the substitution of x upon y is equal to v, right? X is equal to vy. Again, you will find that this your function will reduce to your variable separable form, and integration can be carried out easily. So let us start exercise 9. And the first question is, in each of the following questions 1 to 10, show that the given differential equation is homogeneous and solve each of them. So let us see the first question. Now how to check whether it is homogeneous or not. So dy by dx is equal to your what we call as f of xy. This is equal to your x square plus y square upon x square plus xy. So clearly you can see that the degree of each individual term, so degree of x is 2, y is 2, x is 2, and 1y, it will also be 2. It's a homogeneous differential equation, but we need to check it that the degree is, or it is a homogeneous differential equation. So what we will do, check out f of lambda x, lambda y, right? So it will become your lambda square x square plus lambda square y square upon lambda square x square plus lambda x, lambda y. You can take lambda square common from the numerator and denominator. So it will be your, right? So what we will get? We will get that it becomes same as f of xy, and lambda raised to power 0 here, right? Because it is reduced. So it is your homogeneous equation. It is homogeneous differential equation, right? Now for this form, this is of the form of dy upon dx equal to f of xy, right? So for this, what do we substitute? We put y is equal to vx. Now differentiating both sides, dy by dx is equal to v plus x dv by dx. Right? ddx of x is 1. Now in your this given equation, which is your equation number 1, 1 implies dy by dx is equal to your x square plus y square upon x square plus xy. Now here we will replace dy by dx with this and your y by vx. So we will get it as v plus x dv by dx. This is equal to x square is x square because the substitution is for y only, or you can express the form of y upon x, that is also the way, but it can be carried out like this also. So it is plus v square x square upon x square plus x vx. So you can take x square common because the whole of question now will change in the form of x and v now. So it is x square 1 plus v, right? So x dv by dx. Now I will take this v to other side because I am going to separate the variables now, minus v. So this becomes 1 plus v square minus v square. Be careful with the signs. So it will become your x dv upon dx is equal to 1 minus v upon 1 plus v. Okay. So let us separate the variable because just v and x are there. So it will be cross multiply 1 plus v upon 1 minus v dv is equal to dx upon x, right? So we can see that now the variables are separated, and using variable separable method we will integrate. So for integration, how will we do the integration? Either you can, because the degree of the terms is same, either you can go for that quotient plus remainder upon denominator, okay, but you can split it also, dv plus v upon 1 minus v dv, and this becomes your log mod of x, right? So this also becomes log of 1 minus v and upon minus 1, because integration of 1 upon 1 minus v will be log of 1 minus v, and you have to divide with the ddx of 1 minus v also, ddv of is your 1 minus v also, and this is plus. Now here what you can do is you can either means will add and subtract minus 1, but firstly, because I just need to write it as minus v, because in the denominator we are having minus v, so this is minus v, so it becomes, I will add 1 here and subtract 1. So since integration is not complete, so I am not putting the sign of constant, okay, dv plus, I will split it like this, 1 upon 1 minus v dv log mod x. So this thing implies minus log mod 1 minus v. Minus this will be 1. So it will be just v plus log mod 1 minus v upon minus 1 is equal to log mod x. So the constant here will be c, because we are not going to take log c, because if all the integrals are resulting in log, the constant will also be of log, right, for simplification. So as we will get minus log 1 minus v and minus log 1 minus 2 times log 1 minus v, right, and this is your minus v, right, and which is your log of x plus c. Okay, so we get log of 1 minus v raised to power minus 2 minus log x, you can check, and that will be v plus c. We get minus 2 log 1 minus v minus log x is equal to v plus c. Let us take the negative sign common. So it will be log of, and apply the formula of n log m is equal to log m raised to power n. So it is 1 minus v square plus log x is equal to v plus c. So this thing implies log of a plus log b is log of a into b, and shift this negative sign here. Okay, so let us replace, y was vx, so let us replace here. We were having v by y upon x. Okay, so it will be x into 1 minus y upon x whole square minus v plus c. Okay, so this becomes log x minus y upon x whole square is equal to minus v plus c. So we will get log of x into x minus y whole square upon x square. This is minus v plus c. Let us take the anti-log, and you know log from this side will be removed and this side will raise to power e. So this side can also be written as this into e raised to power minus c. Now you can replace, as this is also a constant, so you replace it with some arbitrary constant a. So we get x minus y whole square upon x is equal to a times e raised to power v can be replaced by y upon x. So x minus y whole square is equal to your a x e raised to power minus y upon x. Question number 2 says this is dy by dx is equal to x plus y upon x. Now simply as you can see that this differential equation is of the form of dy by dx is equal to f of xy, as you can replace as f of lambda x lambda y. So this becomes x plus lambda x plus lambda y upon lambda x. You clearly can see that it will become your lambda raised to power 0 times f of xy, right? So clearly it is a homogeneous differential equation of form dy by dx is equal to f of xy. So what I need to put? Y is equal to vx. Okay, or clearly we can say y upon x equal to v. So here also, if we want to save our time, we can because I have to represent it in the form of y upon x, so we can divide numerator and denominator by x. So what happens? This question changes to, as it is x upon x is 1, or I can simply split it from here. So this will be plus y upon x, because x upon x will be 1. So if we go by this method, then dy by dx is equal to clearly as it is v. Okay, so you know what we need to put now? We will put dy upon dx as v plus, differentiating both sides, x dv by dx. So this becomes v plus x dv by dx is equal to 1 plus v. So we get v plus x dv by dx is equal to 1 plus v. So x dv by dx is equal to 1 plus v minus v, separating the variables. So clearly this is a simple question. So we get dv alone and it becomes dx upon x. So variable separable method is applied here and we will integrate. So this is v and this is log mod x plus c. So who was v? Y upon x. This is log mod x plus c. Or we get y is x log mod x plus cx. Question number 3 is your dy by dx is equal to, you take it to other side, so it will be your x plus y upon x minus y. So clearly also if you don't want to go for that method of checking lambda x and lambda y, you can just divide numerator and denominator by x, as clearly it is of the form dy by dx. So it will be your 1 plus y upon x and 1 minus y upon x, right? So means it is of form f of y upon x. So it is homogeneous differential equation. Okay, so put y upon x is equal to, or y is equal to dx. So differentiating, what do we get? dy by dx is equal to v plus x dv by dx. So let us see what does this equation number 1 becomes. V plus x dv by dx is equal to 1 plus v, 1 minus v. So x dv by dx is equal to 1 plus v, 1 minus v, minus v, 1 plus v minus v plus v square upon 1 minus v, x dv by dx. So x dv by dx is equal to 1 plus v square upon 1 minus v. So this thing implies 1 minus v upon 1 plus v square dv is equal to dx upon x. Right? Now to integrate it, let us separate. Break the numerator. v 1 plus v square dv is equal to dx upon x. So this is your 1 upon a square plus x square, that is the formula of 1 upon a, that is 1 upon 1 tan inverse v minus, here it is f dash x upon x form. So 2v dv is equal to dt. So we get v dv is equal to dt by 2. So I get it as minus dt by your 1 by 2 outside, and this is t, and log mod x. So still integration is not complete. Minus half log mod t is equal to log x and plus c. So let us replace the value of v, minus half log. So this is 1 plus v square, right? T is 1 plus v square. So v square is your y square upon x square. So it will be x square plus y square upon x square. So this is your y square upon x square, right, is equal to log of x plus c. Now for simplification purpose, what we can do is we can take this half to other side, okay, or minus c we can bring to this side, log of mod x plus log of x square plus y square upon x raised to power 1 by 2. I just used n log m is log m raised to power n. So this becomes tan inverse y upon x minus c is, this is log a plus log b, so log a into b. Okay, so this is your, this becomes your, as it was your x square, so x square raised to power 1 by 2 is your x itself, so it will get cancelled here, right? So we will get tan inverse y upon x minus c is log of root x square plus y square. So taking the antilog, I am bringing this to this side, x square plus y square is equal to e raised to power tan inverse y upon x minus c, which can be written as tan inverse y upon x into e raised to power minus c, which can be written as some other constant a tan inverse y upon x. Now question number 4. So x square minus y square dx is equal to minus 2xy dy. Let us express in the form of dy by dx. So dx will come to this side, so it will be x square minus y square upon minus 2xy. This negative sign can be adjusted by just shifting the terms of the numerator. Now clearly the degree of this terms is same throughout. So let us check it by replacing x by lambda x, this by lambda y. It becomes lambda square y square minus lambda square x square upon 2 lambda x lambda y. Clearly lambda square is out from the bracket and it is lambda square 2xy. So we get it is a homogeneous differential equation of degree 0. Right? Why? Because you will find that whatever questions we are solving, the power of lambda is coming out to be 0. Right? We are not getting any power of lambda. So we get homogeneous differential equation of degree 0. It's a homogeneous function of degree 0. So this is a homogeneous differential equation. So what should we put? Of the form dy by dx is equal to f of xy. So what do we substitute? We put y is equal to vx. So dy by dx is equal to v plus x dv by dx. So let us see what one becomes. V plus x dv by dx is equal to v square x square minus x square upon 2x vx x square v square minus 1 x square 2v. So x dv by dx is equal to v square minus 1 upon 2v minus v, which is v square minus 1 minus 2v square upon 2v. So we get x dv by dx is equal to minus 1 minus v square upon 2v. Okay, so we will keep this negative sign to the side of x only. So we are just writing it as v square upon 2v. So we will, when we will separate the variable, as we are using variable separable method, so I will just take 2v upon 1 plus v square to the side of dv and minus dx upon x I take to this side. Right? So it is, you know that it is the form of f dash x upon fx. So clearly I can simply write it as log mod 1 plus v square, and this is your minus log mod x, and we can take the constant also of log. So log 1 plus v square is equal to log c upon x you can take, right? So taking the anti-log, you will get it y square upon x square is equal to c upon x. So this thing implies x square plus y square upon x square is equal to c upon x. So this thing implies your x square plus y square is equal to 6 is the required answer. Question number 7. Question number 7. Here clearly you can see that the equation, even if you check it with the way of dy by dx. So dy by dx here will be, as dx will go to that side, so I'll get it as x cos y upon x plus y sin y upon x, and this is y upon y sin y upon x minus x cos y upon x times x. Okay, so clearly if I replace x by lambda x and y by lambda y, so it will be like lambda x cos lambda y upon lambda x minus lambda y sine lambda y upon lambda x, and this is your lambda y. So lambda y sine lambda y upon lambda x minus lambda x cos lambda y upon lambda x, and this is your lambda x. So you will find that all the lambdas, you will get lambda from here, and these lambdas will get just settled inside only. So we will get this lambda out, and they will get cancelled with the denominator also. Minus y sine y upon x into y upon lambda y sine y upon x minus x cos y upon x times x. So this is homogeneous differential equation again of homogeneous function of degree 0. So this becomes a homogeneous differential equation of the form dy by dx is equal to f of xy, and in such equation we put y is equal to vx. So this thing implies dy by dx is equal to v plus x dv by dx. So let us check it out here in equation. V plus x dv by dx is equal to your x, and this becomes cos v plus vx sin v. So remember, you have to replace y by vx, and x will remain as it is. So this is vx sin v minus x cos v, and it is x here. So x you can take common from the numerator and denominator also, and it will get settled down. So we just will be having, so I take it out x, and let us multiply with this v inside v square sin v upon here you can take x outside. So this is v sin v minus cos v, okay, and x dv by dx, and this is minus v to that side. So we find that we will get it as v cos v plus v square sin v, okay, upon v sin v minus cos v, and it is minus v square sin v, and this is minus minus plus v cos v. So we get it as 2v cos v upon v sin v minus cos v. This is x dv by dx. So let us separate the variable. So we get v sin v minus cos v upon 2v cos v. This is dv and this is dx by x. Right. Now the rest is the scale of integration, but clearly you can just split the numerator. It will become v sin v upon 2v cos v. So v sin v upon 2v cos v, so it will be just half of tan v, right, dv, minus this is cos v will get cancelled, and I will just get minus half of dv upon v, and this is dx upon x, right. So let us simplify now. This is half integration of your tan is minus log mod cos v minus half log mod v is equal to log mod x, and when everything is coming out in log, we will take the constant also of log. So this is, you take the negative signs common, so this will become log cos v, and this is log v, and plus sign will be there, so we can write log of v cos v, and this is log of xc. So after taking anti-log, we will get log of before taking anti-log, I just need to either take this to the side of this, so it will be your log of, because I have to settle this negative sign also, so this becomes your log of v cos v, okay, this is equal to, I can shift it here, log xc, raised to power, because 2 will go to that side and negative sign also I will shift. So this is minus 2 times log of xc, which can be written as log of xc raised to power minus 2, so that I can take anti-log. So v cos v is equal to xc raised to power minus 2. We get v cos v is equal to xc raised to power minus 2. So let us put back v as y upon x, cos y upon x is equal to, it can be written as 1 upon x square c square, right? So 1x will cancel with this and cross multiply, take this x to other side, and this is 1 upon c square. Now 1 upon c square is also a constant, term it as some other constant, so we get the answer as xy cos y upon x is equal to k. Now next question number 10. So this is your question that 1 plus e raised to power x upon y times dx plus e times x upon y and 1 minus x upon y times dy is equal to 0. Right? So clearly you can see that here, if I will just express it in the form that I'll take this ey to other side. Now see what is going to happen. You will observe a very surprising thing, that if I will make dy by dx, it will be your 1 plus, okay, dy by dx. So 1 plus e raised to power x upon y, and it becomes your minus e raised to power x upon y, 1 minus x upon y, which the negative sign you can adjust with e raised to power this upon e raised to power x upon y, 1 plus your, it will become x upon y minus 1, because we are adjusting the negative sign, right? But since you can see that we told you that the two type of differential equations occur, which are homogeneous. One is dy by dx is equal to f of xy, or we call it as f y upon x type, and the second one is dx upon dy is equal to f of xy, or we can write that as f of x upon y, right? So clearly, if it is if we are taking just as it is, so since e is raised to power x upon y, so we must understand that this is actually of this form, minus 1 upon 1 plus e raised to power. Okay, so it is homogeneous differential equation of form f upon xy. So here, what is the substitution? We put x upon y equal to v, or we call it as x is equal to vy. Now we will differentiate with respect to your y. Here we will differentiate with respect to y. So dx upon dy is equal to v plus your y dv upon dy. So we get it as v plus y dv upon dy is equal to e raised to power v minus 1, 1 plus e raised to power v. So y dv upon dy, the whole question is changed to the form of y and v now. So it is v ev minus ev and 1 plus ev and minus v. So this becomes v ev minus ev minus v minus v ev. So let us take the negative sign common here. Y dv upon dy v plus ev. Okay, so let us separate the variables, but keeping this negative sign to the side of dx. So the variables are separated. Okay, now comes the technique of how to integrate now this. Okay, so if you will clearly see, you will find that if I put v plus ev as t, okay, so the derivative of v is 1 and ev is ev, dv is equal to dt. So this becomes f dash x upon fx1. So I get as log mod t is equal to minus log mod x plus the constant now will also be of log. So this is your log of t is v plus ev, okay, and plus log x, you can bring it to this side, so that log a plus log b formula can be applied, which is a into b is equal to log c. So taking anti-log, we just will be left with x v plus eb is equal to c. Let us replace v by your x upon y is equal to c. Okay, so a little bit of simplification we can do, right? We can simplify that okay, we just I think made a mistake because the question was not of x. So this is c. Be careful here because it is your dy upon y, right? Because from the last very few questions we are just solving for x, so we are habitual with x, so please be careful. Y, so this is your y, this is y, so this is y x plus e raised to power x upon y, which can be cancelled with this. Okay, so the answer is x plus e raised to power x upon y, this is equal to c, which is the required answer. Please be careful here because the question now is changed to y and v. Number 13 is your x sine square y upon x minus y times this dx plus x dy is equal to 0. And you this is an initial value problem where you have to get the particular solution where condition is given that y is equal to your pi by 4 and x is equal to 1. Okay, so let us check it out. Now clearly you can see that if I just express it in this particular form, is equal to minus x dy, right? So you clearly know that since y upon x is inverse, so I should make it in the form of dy upon dx. Okay, so what will it give me? Dy upon dx is equal to your dy upon dx will give you x sine square y upon x minus y upon minus x. This negative sign can be adjusted by just simply flipping the terms. Okay, so it is homogeneous differential equation of form f upon f of y upon x. Okay, so what do we put? We put y is equal to vx. So dy by dx is equal to v plus x dv by dx. So this implies v plus x dv by dx is equal to vx minus x sine square v upon x. Okay, so x dv by dx is equal to vx minus x sine square v upon x, right? Where we can take this x sine common, x common from both this numerator and denominator. Okay, and then minus v to this side, v minus sine square v minus v. Okay, so we get, as you can take this 1 upon sine square v to other side, dv is equal to minus dx upon x, and the variables are separated. Okay, now it becomes, for integrating 1 upon sine square y can be written as cosecant square v dv, and this is minus dx upon x. So it becomes minus cot v, and this is minus log mod x plus c. Okay, so log mod x minus cot v is equal to c. So let us replace the values because I am just going to check the particular value of the constant. We will apply the condition when x is 1, y is pi by 4. So it becomes log 1 minus cot of your pi by 4 upon 1 is pi by 4 and c. So log 1 is 0 and cot pi by 4 is minus 1. So we get c as minus 1. Come back to equation number 1. We get log mod x minus cot y upon x. This is equal to your minus 1. Okay. Now a little bit of simplification, we can see that as we know that log e is 1, so minus 1 we can take it as minus log e. So it becomes log mod x minus cot y upon x and can be written as minus log mod e. Okay. So let us bring this log e to this side. So it becomes log mod x plus log e and cot y upon x. So we can apply log e plus log b here. So it will be log of a into b, which is cot y upon x, which is the desired solution. So question number 14. It's a very important question because sometimes you may get confused whether it is a linear differential equation or not. But clearly the involvement of y upon x here and here will show you that it is homogeneous differential equation of form f of y upon x. Okay. And moreover you can check for your lambda also, that if you replace x and y by lambda x lambda y, so it will be lambda y lambda x minus cosecant lambda y lambda x. So clearly you can see that it will be your lambda raised to power 0 f of xy. So it is homogeneous differential equation of form dy by dx is equal to f of xy. So what substitution do we need? We put y is equal to v. So dy by dx is equal to v plus x dv by dx. Okay. So this equation number 1 becomes v plus x dv by dx is equal to here v minus cosecant v. So x dv by dx is equal to v minus cosecant v minus v. So again the same thing we are going to do. Let's take this cosecant to the numerator. It becomes 1 upon cosecant v dv and minus dx upon x. So variables are separated. So this can be written as sin v dv, okay, minus dx upon x. So let us integrate. So integral is minus cos v minus log mod x plus c. Okay. So this is log mod x minus cos v is equal to c. This thing implies log mod x minus cos y upon x, okay, is equal to c. Let us put the condition which is given. Y is 0 when x is 1. So it becomes log 1 minus cos of 0 upon 1 is 0. So this is 0 and this is, you know that cos 0 is 1. So again we get c here as minus 1. So let us come back here. Log mod x minus your cos y upon x is equal to minus 1, which you already know that in the previous question as we did. So log mod x plus log e is equal to cos y upon x. So this becomes log xe is equal to cos y upon x is the required answer. Now question number 16 is just a concept based question that a homogeneous differential equation is of the form dx upon dy is equal to h of x upon y, right? So which kind of substitution we should make? So you very well know, if the equation is of this form h of x upon y, right, then we are going to take the substitution as x is equal to vy. Question number 17, which of the following is a homogeneous differential equation? So see here, we just need to see that the degree of the terms is same throughout. So when we will convert it to the form of dy by dx, when we will take it to other side, it will be your 3y plus 2x plus 4 upon 4x plus 6y plus 5. So you can find that here no variable is there, so it cannot be a homogeneous differential equation, right? So no doubt y is having power 1 here, x is having power 1 here, but no variable is there, so it is not homogeneous differential equation. Moreover, here also you find that degree of this term will be 2 and this term is 3, so degree is not same throughout, so it is also not homogeneous differential equation. So when you will apply this lambda x lambda y, it will not be giving you your lambda raised to power 0 times f of x y, okay, or something else also. So this is again for part C, it is x cube, so degree is 3, here it is 2, here it is again 2, so it is also not homogeneous differential equation. This one is also not homogeneous differential equation. But here in this you will find that degree of y is 2, x is 2, x and y both will give you 2 and y is 2, so it is homogeneous differential equation. So even you can check that f of lambda x and lambda y will give you lambda raised to power 0 times f of xy.